Hi friends, my name is Amita and in this video I am going to discuss about a very important network analysis technique, that is a mesh analysis. Before understanding the mesh analysis, you should be aware about what is the meaning of network analysis. Now, network analysis consists of in two words. As you can see that one is network, another is analysis. Network is nothing but it's a combination of three things. One is input, another is system parameters, means the basic electrical elements, resistance, inductance and capacitance, they are connected in a particular fashion, maybe in series, parallel or a combination of in series and parallel. And third one is the output. Amongst these three things, that is input and circuit parameters and the output, if we know input and the circuit parameters, then to determine the value of output, that is called as a network analysis. Opposite to that, if we know the input and if we know the output, then to determine the value of a network circuit parameters, they are called as a network synthesis. Mesh analysis is a type of a network analysis technique where with the help of KBL, we used to determine the output, that can be a current flowing in any branch of the circuit or the voltage drop across any element of the circuit or the power loss occurred in that particular element of the circuit. Now, without wasting time, I am taking you on the board and where I will brief you the step-by-step process of a network analysis technique, that is a mesh analysis. So, I am going to discuss about, that is mesh. The very important thing about it, it's a network analysis technique. Here the input and circuit parameters are known to us, then determine the value of output, that is current, voltage drop, power loss across the element of the circuit. That is called as a network analysis, and with the help of mesh analysis we can determine the current in any branch of the circuit, the voltage drop across that branch of the circuit and the power loss. So once we know the current, would suppose the current across IR1 is X, then what is the voltage drop across R1 element, that is IR1 into R1. What is the power loss, PR1, that is equal to IR1 ka whole square multiplied by R1. So this is how the unit of this is ampere. This I can write it as X into R1. This I can write it as X square into R1. The unit of this is volts and the unit of this is watts and the unit of this is amp. Now let us try to understand what is mesh and loop. What is the difference between mesh and loop? The first thing is we should understand what is loop. Loop is nothing but it is a closed circuit through which a current can flow. That is called as a current can flow. That is called as a loop. Now what is mesh? Mesh is nothing but it is a special type of loop which doesn't have any other closed circuit inside it. For an example, if I draw this circuit, resistive circuit, suppose this is 10 volt, this is 5 ohms, this is 10 ohms, this is 5 ohms, this is 5 ohms. So if I give the terminology like this, A, B, C, D, E, F, then A, B, E, F, A. The circuit is having three closed paths through which a current can flow. One is this, another is this, and the third one is the current can flow like this also. So there are three closed paths through which a current can flow, A, B, E, F, A, B, C, D, E, B, A, B, C, D, E, B. So the second one is B, C, D, E, B, and third one is A, B, C, D, E, F, A. Now A, B, E, F, A, it's a closed path which doesn't have any other closed circuit. So let's write here loop and mesh. So A, B, E, F, A is a loop. A, B, E, F, A, as it doesn't have any other closed circuit inside it, so it is a mesh also. B, C, D, E, B, it's a loop, as it is doesn't having any other closed circuit inside it, so it is a mesh also. But when we talk about A, B, C, D, E, F, A, it is a loop, but it cannot be a mesh because it is having other closed circuit inside it, that is A, B, E, F, A and B, C, D, E, B. So it cannot be a mesh. So that means I think now the difference is clear. Every mesh has to be a loop, but every loop cannot be a mesh. So I think now it is clear that what is the difference between loop and mesh. Now let us try to understand mesh analysis. There are very first thing about it, it is applied on mesh to the analysis of the second thing is it's a application of Kirchhoff's voltage law. And the third thing is here KBL is applied on masses to determine the current oblique voltage drop oblique power loss in a particular branch of the circuit. And the very important thing, it is a technique of network analysis where we solve the circuit in the fashion as it given. Now the important thing, as it is the application of KBL, so we should understand what is Kirchhoff's voltage law, that is KB. The first thing is, it is the second law of Kirchhoff's, and the statement of Kirchhoff law is the algebraic sum of voltages in any closed loop is equal to 0. Means this law is based on energy conservation principle. Energy conservation. Now, there are few standard sign conventions in a Kirchhoff voltage law. Sign convention in Kirchhoff's voltage law. Like if there is a voltage source like this and the current is flowing like this, then we will write always in a KBL equation plus V, because the current is flowing in a voltage rise way. Similarly, if the voltage source is like this and the current is flowing like this, then it in a KBL equation it will written as a minus V, because it is a voltage fall. the current is flowing in a voltage fall way. Apart from this, if there is any passive element, whether it is a resistance or inductance or capacitance, when the current flowing through this is like this, so always the entering end of a passive element will be positive and the leaving end will be always negative. So across the passive element, always current flows in a voltage fall way. So always the voltage across the passive element, we will write it as, suppose this is I, this is I, this is I. So we will write here V is equal to the voltage drop, we are going to write minus R into R. And here also minus L di by dt. And here minus 1 by C integration I dt. And if the XL is given, we can write I into XL, minus I into XL, and minus I into XC. So always passive element voltage drop will be negative. So general sign convention is voltage rise, we will consider it as a positive, and voltage fall, we will consider it as a negative. So this sign convention we are supposed to follow. Now let us discuss about the main method, that is mesh analysis. Now there are steps that we need to follow. The first step is identify the meshes in a given circuit. This is the first step that you are supposed to do. Then second thing is name the meshes available in the circuit. Like A, B, C, D, E, F, A. Third one is assume the current in each mesh either clockwise or anti-clockwise. But if we are taking clockwise, then in each mesh it has to be clockwise. Or vice versa. That means if we are taking anti-clockwise, then every mesh has to be anti-clockwise. Now after this, the fourth point is write the KBL for each mesh. Then solve the equations to determine in the desired branch. So let us try to solve one circuit, a very simple circuit that I am giving to you. Suppose this is 10 volt, this is 5 ohms, this is 10 ohms, this is 15 ohms, 5 ohms, 5 ohms and 20 ohms. My objective is to determine the value of current in this 20 ohm resistance using mesh analysis. So what is the first step? Identify the meshes. So let us give the name A, B, C, D, E, F. Now how many meshes are there in this circuit? There is a 2 meshes. Mesh 1, that is A, B, E, F, A. A, B, E, F, A. And the second mesh is B, C, D, E, B. Now the second step is assume the current in each mesh either clockwise or anti-clockwise. So I am taking clockwise. So there are two meshes. So I have taken current I1 and I2. Now the third thing is write the KBL equation. Again the concept is voltage rise positive and voltage fall negative. What is the KBL equation? 10 minus 5 I1, voltage drop across this is minus 5 I1, minus 10 I1 minus I2. Why? Because 10 is the common element between mesh 1 and 2. So when we are writing the KBL equation for this 10, we assume that the current in this mesh, that is I1, is higher than I2. So what will be the current? I1 minus I2. So when I1 is higher than I2 means the direction of current will be from upward to downward. So that means the current is flowing in a voltage fall way. So minus 10 I1 minus I2 and minus 5 I1, that is equal to 0. If you solve it, that is 10 minus 5 I1 minus 10 I1 plus 10 I2 minus 5 I1, that is equal to 0. So what is the final equation? 5 I1, 10 I1, 15 I1. So means minus 20 I1 and plus 10 I2 plus 10, that is equal to 0. This I can write it as 20 I1 minus 10 I2 and minus 10 is equal to 0. So finally I can write it as 20 I1 minus 10 I2 is equal to 10. This is equation number 1. Now what is the equation for mesh 2? That is minus 15 I2, that is the voltage drop in this. What is the voltage drop in this? Minus 20 I2 minus 10. Now this element we are considering for mesh 2. So mesh 2 means I2 is greater than I1. So minus 10 I2 minus I1, that is equal to 0. Now if I further expand it, so minus 15 I2 minus 20 I2 minus 10 I2 plus 10 I1 is equal to 0. So what I am going to get? 10 I1, okay, then 30 minus 35 I2, that is equal to 0. This is equation number 2. So what are the equations? Finally, the equation number 1, that is 20 I1, equation number 1, 20 I1 minus 10 I2, that is equal to 10. And what is the equation number 2? 10 I1 minus 35 I2. So 10 I1 minus 35 I2, that is equal to 0. This is equation number 1. This is equation number 2. Now solve the equations. So and determine the value of I1 and I2. So 20 I1 minus 10 I2, that is equal to 10. Multiply equation number 2, multiply equation 2 by 2 and subtract from equation 1. So what I am going to get? Equation 1 is 20 I1 minus 10 I2 is equal to 10. And if I multiply the equation 2 by 2, so that is 20 I1 minus 70 I2, that is equal to 0, and subtract it. So what I am going to get? This cancel. 60 I2, that is equal to 10. So I2 is equal to 10 by 60. So 1 by 6. So 1 by 6 ampere is your I2. This is what we are supposed to determine. We are supposed to determine this I. So this is equal to I also. Similarly, if we are supposed to determine I1 also, so what we can do, put the value of I2 in equation number 1. So what I am going to get, 20 I1 minus 10 into I2 की value 1 by 6, that is equal to 10. So what I am going to get, 20 I1 minus 10 into 1 by 6, that is equal to 10. Now from here 20 I1 is equal to 10 plus 10 by 6. So 70 by 6, that is 20 I1. So I1 की value is 70 by 20 into 6. So what I am going to get, 7 by 12. So I1 is 7 by 12 ampere and I2 is 1 by 6 amperes. This is the answer. So finally I1 is 7 by 12 ampere and I2 is equal to 1 by 6 ampere. This is the. Now I'm stop sharing my screen. My dear friends, whatever information related to mesh analysis I have shared in this video, I hope you understood well. Now you are able to solve the numericals based on the mesh analysis. The steps are very simple. Identify the meshes in the given circuit. Then assume the direction of current in each mesh, either in clockwise or in anti-clockwise direction. Then write the KVL by taking the assumption voltage rise positive, voltage fall negative. And after formulating the equations, then we are supposed to solve the equations to determine the magnitude of current in each and every branch of the circuit. Like in a given example, I have determined what will be the current across, or what will be the current through 20 ohms resistance, that was I2. So my dear friends, if you like this video, kindly press the like button. And if you feel that whenever I make video related to network analysis, a notification should reach to you, then don't forget to subscribe my channel. Thank you very much. Thank you very much.